For implicit differentiations, we derive term by term, each term with respect to x. For instance, if I want to derive x squared with respect to x, I have 2x. But if I want to derive y, because y is a function of x, if I derive y with respect to x, I have dy dx. If I derive y squared, I have 2y dy dx. We could write our dy dx as just y prime. So I can say 2y squared is 2y, then y prime. Any which way that's okay for you, you can do it. So I'll come back to this expression. I'm going to derive each term with respect to x. So if I take x squared, I only have 2x. But if I take 2xy, I see a product. So I have to deploy the product rule here. So I'll keep my 2, hold x and derive y. I have x and y prime. Now hold y and derive x. If I derive x with respect to x, it's just 1. So I have y again. And plus, if I derive 3y squared, I have 6y with respect to x. So 6y and dy dx, I call it y prime. If I derive 12, of course, that is just 0. Then I can simplify these expressions and make my y prime or dy dx the subject. So I have 2x plus 2xy prime plus 2y plus 6y y prime equals 0. I'll keep all the y primes to one side. If you don't have y prime, move to the right hand side. So I have 2x y prime plus 6y y prime equals negative 2x negative 2y. I can factorize y prime out. I have 2x plus 6y. This equals negative 2x negative 2y. Then if I need my y prime, I can divide through by 2x plus 6y. So y prime is negative 2x negative 2y all on 2x plus 6y.